Now let's look at some reconstitution problems where we're asked to make a mixture of a particular concentration. In the first example, we have a vial of doxorubicin reading 0.5 grams per vial. Our instructions say to reconstitute each 12 milligrams with 2.5 milliliters of natural saline. How many milliliters of natural saline will then be needed to reconstitute the vial at the recommended concentration? So what we need in this case is to find the number of milliliters per vial needed for our recommended concentration. We have in our vial 0.5 grams. The instructions read that for each 12 milligrams, we'll need 2.5 milliliters of natural saline. So the first thing we'll need to understand is that because we're given in grams per vial, it would be helpful to make the conversion from grams to milligrams. So our conversion here would be something like 1,000 milligrams for every 1 gram. So that will tell us the number of milligrams per vial. And now we can multiply again by our instructional phrase here, the 12 milligrams being reconstituted with 2.5 milliliters. So in that instance, we'll have milliliters on top because that's what we want to end with 12 milligrams in the denominator. With our particular units here canceling, we're left now with milliliters per vial needed. Through the computation that we have here, we should get something like 104.16 repeating milliliters per vial. So as per usual, we have something here that we probably need to round, in this case to the nearest tenth. So we'll have 104.2 milliliters needed per vial to do the proper reconstitution and obtain the correct concentration. In our second example, we have instructions for a 2.5 gram vial of chlorothiazide reads to reconstitute with 20 milliliters of sterile water. This provides a concentration of how many milligrams per milliliter? So the end goal is stated much more clearly in this case. We want to know how many milligrams per milliliter we'll have at the end of this. So again, we start with what we have, 2.5 grams per 20 milliliters, and multiply by a proper conversion. All we really need is to make the conversion from grams to milliliters. So we have, again, 1,000 milligrams for every 1 gram. Canceling our units here, we have grams canceling, leaving us with milligrams per milliliter as desired. And our calculation here should get us something like 125 milligrams per milliliter